In this problem, we let w equal to r times cosine alpha plus I times sine alpha, and z equals to s times cosine beta plus I times sine beta. Express w times z in polar form. So first, we can do a recap of what it means to write a complex number in polar form. So if you have a complex number like z equals to x plus iy, then the polar form of z will be r times cosine theta plus I times r times sine theta. And this can be simplified as r times cosine theta plus I times sine theta. So the x and y are coordinates in rectangular form, while r and theta are coordinates in polar form. So then we can write wz equals to r times cosine alpha plus I times sine alpha times z, which is s times cosine beta plus I times sine beta. Then you can rearrange these and become rs times cosine alpha plus I times sine alpha multiplied by cosine beta plus I times sine beta. Expanding the parentheses will give us cosine alpha times cosine beta minus sine alpha times sine beta plus I times sine alpha cosine beta plus I times cosine alpha sine beta. Then notice that this is in a familiar format. It is in the format of cosine times alpha plus beta and sine of alpha plus beta. So the real part of the expression is cosine times alpha plus beta, and sine times alpha plus beta is the imaginary part. And I cover the sum and difference of angles for cosine and sine in different videos that you can check out. Then, so after simplification, this equals to r times s times cosine alpha plus beta plus I times sine of alpha plus beta. And that is how you express w times z in polar form.